In this project, we build an end-to-end data and AI solution to help a Canada-wide rental company turn raw data into actionable insights. The company has access to large volumes of rental listing data across different property types, but extracting insight is slow and highly dependent on technical team. Our goal is to simplify this process by enabling natural language interaction with the data. We start by ingesting multiple datasets into a centralized Snowflake environment, then transform and standardize the data into an analytics-ready format. Using a scalable data pipeline, we unify information across apartment, condo, house, and basement into a single consistent model. Next, we introduce a semantic layer to make the data more understandable for business users. Finally, we integrate AI-powered query, allowing users to ask questions in English and receive instant data-driven answers. By the end of this project, you will see how modern data platform and AI, such as Snowflake, can work together to eliminate manual analysis, accelerate decision-making, and make data truly accessible to everyone. Hello all and welcome to this video. In this project, I'm going to show you very specific project which shows the combination of SQL, Python, and AI. The case that we have is a Canada-wide rental company which has a lot of data about the property, but they're looking for a way to talk to their data and get the insight. So this project is a kind of modern architecture case study. We have a rich data, but those data are trapped by code. That company has a lot of data. They have been working for several years. So it makes sense they have a lot of data, but they need to extract some information about that data. And doing some data analysis for manual SQL query takes a lot of time, and it's not aligned with the market responsiveness. So what they want, they need the instant insight, which is powered by AI. So in this project, we, as a data scientist and data analyst, we are going to centralize a data process pipeline with Snowflake to apply a semantic translation layer. What does it mean? It means we are looking to build a natural language query to enable the managers, the stakeholders to talk with their data and get the insight. So what's the benefit? The benefit is unification. We automated all the pipeline and the process is super integrated. We increase the acceleration. Instead of hours SQL query manually, we just do it very short in a second and independent. So this is totally serverless because all the process is going to be done on a Snowflake. Now let's talk about the data. The company has a lot of data about the different properties in different provinces and different cities in Canada. So those data have categorized in 4 sections: apartment, condos, houses, and basement. And each of them has a lot of data in terms of the bed, number of the bathroom, which city, or the listing date, the prices, so on and so forth information. But those data are very fragmented and scattered, and it is not good for getting the insight. So we need to categorize this kind of information as a structured data to have this capability to implement our project. So in terms of the role, in this project, we have 2 different roles. We have the business stakeholder side. The goal is maximizing market responsiveness and agility. And in terms of the system frictions, they cannot run the data by itself because they are managers. They have different skills. They would like to make decisions based on their experiences in management, in business. And the operational consequences that the decisions they need, they are totally dependent on the data and insight they get. On the other hand, for data analyst side, the goal is building the advanced analytics, architecture, and complex modeling. And the system friction is that we should try to make the routine, the SQL queries, specifically for basic business questions, because this kind of chat is some kind of ad hoc questions. If the managers need so many details, definitely we need a senior data analyst or data scientist to deep in dive for those kind of questions. But for the basic questions, it's not good to just the manager just ask somebody to come to their room and just write a query. They can have this capability to chat with the semantic model and just grab the data. But if they need more in-depth data, more depth data analysis, yes, they should go and ask the data department. So the full architecture is that we have 4 different data. We are going to ingest them to a central warehouse, which is called Snowflake in this project. And we automate all the pipeline for data ingestion, which is the connection between AWS and Snowflake. And after that, we build that semantic model inside the Snowflake. So if you're ready, let's get started. Okay, the first step for our project is upload the data that we have in a blob storage or in a container. We have a bunch of options for doing that. We can upload directly in a Snowflake. We can use some cloud platforms, or even we can use our local machines. I prefer to use the cloud platform, and I choose the Amazon. Amazon S3 bucket is the option that I'm gonna choose. Here, first of all, I select the area which is the nearest place to me. And after that, I'm going to go to S3 bucket to upload my whole data. I just search it here, S3, and go to S3 bucket. As you can see here, I have uploaded the data that I would like to have. I just call it the Canada rent. And if I go inside this bucket, you can see I have 4 different CSVs. We have rent apartment, which shows all the data about the apartment. We have also the same information, not in terms of the data, in terms of the number of the columns. We have basement, we have condos, and we have houses. So it means we have 4 different property categories, and we would like to go ahead with these data. So our data in AWS S3 bucket are ready to go ahead and do some steps in Snowflake. Now that we have our data in S3 bucket, it's time to ingest those data to a Snowflake somehow that we can use it. But before doing that, we should have a place in a Snowflake to let that data sit here. For example, here, if I go to the database, you can see I don't have anything. I should create a database, have that place for AWS S3 bucket to just let the data live here. So I go and add a new SQL file, and I would like to call as create warehouse. So here I should create a data warehouse, a database, and one schema for raw data. During the project, we will have more than one schema. It makes sense because the data, we have raw data, then we have transformed, and now we have analytical, so many different schemas. But the first step is that create the schema to bring all the raw data from AWS. So first of all, I'm going to create warehouse if not exist. And I'm going to call this data warehouse Canada warehouse. After creating the warehouse, I should create a database inside this warehouse. So I say create database if not exist. However, it should be also if not exist, and I'm gonna call it rent.db. And the next one is that we have the warehouse, we have the database. Now it's time to create a schema. Create schema if not exist, and I'm gonna call it raw. It is one schema. As you can see here, I don't have anything. I don't have warehouse. I don't have any selected database. So I select all of them and then I run it. When we run it, you can see we have a schema raw successfully created. And now we have Canada warehouse. Inside this warehouse, we have one database as a rent database, and now we have raw schema. Even if I go to the database, just refresh, we have one database as a rent and one schema as a raw. Now everything is ready to bring the data from AWS to this raw schema. Now it's time to ingest our data from AWS to the Snowflake. Before doing that, we should go to the AWS and create a user and assign the full access of S3 bucket to that user. Otherwise, the AWS or other cloud platforms don't allow other third parties, data warehouses like Snowflake, be able to connect with that cloud platform. So let's jump to the AWS. Okay, now here I should go to IAM, manage access for AWS. Here I should go to the users, and I created a user which is called Snowflake user. And as you can see, this user has access to Amazon S3 full access. It means this specific user is able to do whatever she wants for the S3 bucket. Also, for security credentials, I created access key. Without access key, you cannot connect the AWS to Snowflake. So this is my access key ID. Also, AWS provided me with a password that definitely I'm not going to show the password in the recording video. Now everything in this side is ready. Now we can jump back to the Snowflake. Now here I go to the workspace and create a new SQL file and I call it data ingestion. First thing is that I'm going to first connect to the warehouses, the databases, and the schema that I'm going to use. So I say use warehouse, and the warehouse that I'm going to use is Canada warehouses. Then use database, and I'm going to use the rent database. I'm just going this database, and then the schema is that use schema, and I'm going to use the raw schema that is here. Now, I can run the query or I can just simply select from here. So I prefer to run the query as like that. Now, again, the Canada warehouses, the rent databases, and the raw schema are there. Now, the next step is that I'm going to make connection. To make connection between the AWS and the Snowflake. I say create stage. And I'm going to call it, for example, raw data ingestion. And I should provide with the URL. And this URL is nothing but my S3 bucket name. So how can I get that? I go to the AWS again, go to the S3 buckets, and go inside the S3 bucket. And this is my S3 bucket's name. The Canada rent. That's it. Just copy that, and now we can go to the Snowflake. Here I should say S3 / and name of the S3 buckets. Now the stage is ready. Next step is that I'm going to say credentials is equal to things. One is AWS key ID, which should be something. And then we have AWS secrets key or password, and it's gonna be something else. So I'm going to provide these two things and then run the code. So as you can see here, the stage area for raw data ingestion successfully created. So it means inside this database, if I refresh it, we have inside the raw schema, we have one stage which is raw data ingestion. So we made a connection between the AWS S3 bucket and the Snowflake, but we have not yet brought the data in the Snowflake. This is the next step. So in the next step, we are going to create tables. So I paste this piece of code and let me explain line by line. We have 4 different tables because we have 4 different CSV files. We have for rent apartment that we want to call as a raw rent department as the name of the table. Based on the column and based on the data type, I just would like to create or replace a table. And the last column, I'm going to add one more column to mention when the data is ingested from AWS to a Snowflake. The second table is for second CSV file, which is for rent houses. We have the same columns, and I also added one more column as the last column for loaded. Also, we have for condos and we have for basement. All of them I'm going to run, and then you can see in a raw schema we have 4 different tables. I just select all of them and go ahead and create those tables. And as you can see, all those tables are created. Just go for database and refresh. I go there, and as you can see, we have 4 different tables here. Definitely, all of them are empty because we have not still uploaded the data inside these empty tables. For uploading the data, I say now ingest data from AWS to Snowflake. So for uploading data, this is a piece of code that I'm going to explain. First of all, we are going to copy data to raw rental apartment, this empty table. But which columns? I'm going to say all the columns except the loaded at. So I explicitly mention which column. This is the best way to not getting any error. If you just simply say copy data from S3 bucket to Snowflake, you might get error, but I explicitly mention which columns. Then I say, okay, this data is gonna be copied in this table, but from where? I say from this raw data ingestion that we just created above. And then from which CSV file in AWS? From rental apartment CSV. This is the name of the file in AWS. And after that, the type is CSV, and just because it's a CSV, the first row should be skipped. And after that, if we see any error, just continue. The same process for houses and condos and basement. So I select all of them and go ahead and run it. Now the data is being uploaded from AWS to Snowflake. And as you can see, all the data is loaded. Just go and refresh the schema to see the table. Just for a test, I'm going to say, for example, select everything from, for example, raw rent apartment. Just for a test to see the data is there or not. Yeah, definitely data is here. This is for apartment. We have listing ID, which city, which province, the home type, number of the bedroom, the bathroom, square feet, and all the informations. And also the last column shows when I uploaded the data inside the Snowflake. So all the tables are ready. Even I can just go for the other one, for example, basement. Let's run the basement and see. Yeah, all of them have the same columns because we just defined in such a way. Now data and raw data is here. Now we can move on to the next step of the project. All right, in the next step, I'm going to work on the raw data that we just stored and do some transformation. And after that, save that data in a new schema as a new version. For example, analytics or production, anything. But this data is raw right now, so we need to do some modifications or transformation. So here I'm going to do that. So I go and open a new file, and this file is going to be a notebook because I'm going to work with SQL and Python in a notebook file. So I go and create a Jupyter notebook, and I call it as a transformation. And we can open the file, just close it to have more space, just a bit. Okay. First of all, we should connect this notebook to the warehouses and the compute that we have. So I go ahead and click on the compute, and as you can see, this is my compute. I can just select it, and the compute is gonna be resume. Okay, now the compute is run, and we can start to do some transformation. First of all, I'm going to import two libraries. Let's say import libraries, and inside it I would like to have these two things. They are the Python library. One of them is the Snowflake Cortex, because when I'm working with a Snowflake inside the notebook, I need to have the session log. And after that, I'm going to import pandas because we are dealing with some kind of data frame. Then I run. Now we have two of these libraries ready, so we can go ahead. In the next step, I'm going to load raw data. And I say, okay, we have 4 different things. Let me go to the database to have, just refresh it. Okay, we have 4 different data as a raw. We have rent raw apartment, which is here. We have basement, which is here, condo and house, condo and house. Each of them I'm going to store as a different data frame in a pandas. And before that, I'm going to make the session. This session is the library we just imported. And after that, we just active that session. So we active the session inside the Snowflake. And after that, that session is working as a connector between Python and SQL. And then I can just call these raw table stored in a session, and after that I convert it to the pandas data frame. I run all these cells to convert the SQL. Okay, let's just give it a try to see. It's this one, head, let's say 5. Just run the Python. For the first time it might take time. Yeah, the data is here. We have for the houses, even for condos. I just want to make sure all the data is converted to the data frame. Yeah, this is exactly what we saw previously in SQL. Now we are seeing in a Python. Okay, now we can go ahead and do some transformation. All right, the next thing is that I'm going to profile the data. Data profiling. To see, do we have any null values? Do we have any duplicates? What is the data type and anything? I'm going to make a function for doing that. I'm going to say I have a function as a profile raw table. This function has 2 arguments. One is the session. This is just a default argument. And the other one is the table name. So after that, that data should be in a pandas data frame that we are pretty sure because we just created and converted to the data frame pandas before. Then that data frame is gonna be loaded based on a modular format. I mean, all of them should come from the rent DB, which is our database here. And after that, they converted to the schema and then just read the table name. And for every single table, I will have 5 columns. One of them is just number of the columns or name of the columns that table have, the data type, how many null values they have, how many unique values they have, and just give me some samples. This is the function that I just run it. Then I'm going to make a list. This list is gonna work as a table name. So I'm gonna say, okay, all the raw data that I have are stored in this table. This table name, all of them should be here. The raw rent apartment, raw rent basement, condos and houses. Then I just run the list to have name of all the tables. And then I say, okay, I have the function, which is this function. And for the session, this is the session. And the table is every single item in a raw table. It means each of these values is gonna work as a table name. And this is just the name of the table. Before that, we have a schema. And before that, we have just the database name. So I just run it, and I will expect to have 4 different tables based on a different information for my different just the raw data. For example, the raw rent apartment, we have columns. This is all the columns that they have. This is the columns type, number of the null values, the distinct values each of them has, and just give me one sample for each. You see we have no null values. That is great. Let's go for the other one. For example, the basement. Again, the columns name, the data type, number of the null values, distinct values. The next one is just the condos, and the last one is the houses. And as you can see, we just have the data profiling so clean and nice. All right, in the next step, I'm going to have one single table. I mean, as an appended table, as a merged table, to concatenate all these tables as a one data frame. So I go and create another file, and I say appending data, and I paste this piece of code. Okay, again, I have the tables, all my tables, as a dictionary. So I say, okay, these raw tables, I'm gonna call it as apartments. This table, I'm gonna call it the basement, this one condos, and this one house. This is my dictionary. And after that, I create an empty list, and I say for every single table name here, for every single of them, create a property type, which is apartment, basement, condo, or house, which is coming from this dictionary for every single item. Append them together. So it means we are going to append all those data, and finally we create one new column which is called property type. The property type later is either department or basement or condo or house, and then put all of them as the data frame on. So if I run this piece of code, and now if I just run, for example, this one as a sample, let's say 5 samples for this data frame. Let's see. If I scroll down all the way to the right, you see some of them are basement, some of them are house. Even if I just make a new sample, you see we have one new column as a property. Even we have apartment and basement. So we have all data, all these tables as one single table. But okay, we have the data here, but we need to push this data in a new schema because we are working in a raw. But I'm going to push this old data as a new schema inside this database. I should create a new schema here. Let's call it analytics. And I'm going to create this schema. You can see now we have analytics as a new schema, but this is totally empty. I'm going to push this data to that schema. I think I'm going to create an object which is called snowpark.df, and again I will take advantage of session, and I pass this data frame inside that session. Now session is ready and asked, okay, what am I going to do? I say, okay, let's go and overwrite if it exists, overwrite on that, and save the table as inside the database, inside this schema, and this is name of the table inside that schema. So I run the query. You can see now we have a new table, which is an append or the merged version of all this data. Now we have one single table, then we can run some exploratory data analysis query on that table. All right, now it's time for the next phase of the project, which is exploratory data analysis. I'm going to make a new SQL file and say EDA. And just because all the EDA is in the SQL, I just created the SQL format. So first of all, I'm going to select the warehouse and the database. And now this time I'm going to select the analytics schema, not raw, because now we have all the data in this schema. Let's start the first query. Okay, the first query is that average rent by city. So we are gonna select the city, the province, the monthly rate, and we are gonna do some analysis on that. From all the rental, which is our final tables, I'm going to group data based on a city and then based on a province. And for each of them, I'm going to do something. First of all, I'm going to say number of the records each of them has. I'm going to call it as a total listing. Then average of monthly rate for each of them. I'm going to round it 0 decimal, just round down, and call as the average monthly rate. Then minimum monthly rate, maximum monthly rate, just a standard deviation for more statistical analysis. And then whenever I have everything, I'm going to sort the data based on a monthly average rent. So I run it, and then I run the query, and as you can see, we have the data here. We have Vancouver in a province for BC, British Columbia. Number of the lease in Vancouver, we have 150. The average monthly rate is almost 3,700. The minimum rent is 1,600, and the maximum rent is 6,600. If I would like to see the chart, you can see just different data based on a bar chart that we have, and you can work with different axes if you like. So this is the first query, and as you can see, the Vancouver and Toronto, and after that the Victoria, has the highest average monthly rate because the data is sorted based on this column. Now we can move on to the next query. All right, the next query, I'm going to say, okay, from this table that I have, I'm going to group data based on a listing year or every single year. Just let me down for every single year and single months, or it means in which year and which months based on these two groups. I'm going to just do something. First of all, I'm going to concatenate those data that I have, the listing year and the listing months, just as a period, the first day for each of them. Then I'm going to say how many records each of them they have based on this grouping, and just find the average rent. Let me run the query. And as you can see, for example, in 2022, in month 1, in January, which starts from 1st of January, it's coming from this piece of code. The number of the listing, only in January, we have 56 number of the listing. And the average rent for those listings was 2,500 almost. But when we go to that February, even though number of the listing dropped from 56 to 45, the average rent increased. And if we move on to the March, again, number of the listing increased and average rating increased this time. And all the information, you can see the last one is 2024 December. This is the second query, and now we can move on to the next query. This time I'm going to find the top most expensive cities per hometown or per city. So I'm going to say, first of all, from the data that I have, group the data based on a home type, city and province, group the data, and just bring me monthly rent. What is the monthly rent? Because I'm going to find top most expensive. So I'm going to say, based on a monthly rate, I'm going to rank the data, partition by home type as the question asking, and I'm going to order based on a monthly rate descending. Then when I have this query, I put it as a CTE. And then just because I ranked for every single item, I have, for example, for this home type, I might have 1 to 20. But for each of them, I need only 5. So I keep the rank only 5. Then I'm going to run the query. You can see, for example, here, for home type as an apartment, in the city of Vancouver, which is in province of BC, the average rent is $32.88. which stands in a first rank. In that home type for apartment, in another city, which is Toronto, the second place is 2861 for Toronto. Again, in that home type, Victoria stands in a third place with 2784. This is for apartment. Now we have all top five and most expensive. Now, if we move on to the basement, again, Vancouver stands for the first row. What about the condo? If I go for the condo, again, Vancouver and a house Vancouver. So it means Vancouver has the most expensive property across the Canada, which makes sense. All right, now we did all the process, but a stakeholder needs something else still. They want to have the ability to chat with this table. They would like to ask some question, and then the query is run automatically and reply them. This is so interesting, all right? And Snowflake has this capability. Let's apply all the process for these things and provide the stakeholders with these fantastic features. So I go to the AI ML sections and go to the analyst sections. Here, I should create that models. So I go and select the database and I say this is the rent and which schema, definitely analytics. So here I'm going to create the semantic view. Semantic view means, okay, I have the table, I have the schema. Now I'm going to make some capability to run SQL automatically based on a question that I ask. I go there and create with autopilot. Here, this is just to provide context. It doesn't matter. You can even go with SQL query or Tableau data source. It doesn't matter. You can skip it. It is optional. I skip that one. Here, I should write the name. I can say, for example, Canada, let's say rental price. And this is semantic view. And the schema is a rent database and analytics as the schema. I go ahead and click on next. Here, I would like to make sure I selected the correct one, rent database, analytics schema, and which table, definitely all rental as the schema. I go ahead and click on next. Here, I should mention which columns I would like to provide the AI model to just fetch all my data. I say select all of them, but I don't need some. For example, I don't need the loadeds, or I don't need, for example, the listing ID. But for listing ID, let's keep it. Maybe we need it for some aggregation. Yeah, that's it. And I go ahead and create the ads application. All right, now you can see our semantic model is deployed. For example, you can add the custom instruction. You can add the description for the end user to know what this file is. Or we have the logical table, or the table that we just made a query. For example, number of the dimensions. How many dimensions do we have? We have bathroom, we have bedroom, city, so on and so forth. Also, we have the time dimension. And these dimensions are storing the columns only related to the date, because in that case, the AI model can understand the question is related to time, period, or these kind of things. And also we have some other information here. But let's give it a try and ask a question about this data by the AI model. So I open the chat. Now you can see the chat is telling me this dataset contains the Canadian rental listing data, all the information. So we can give it a try and ask a question. For example, I would like to ask, in 2023, which city had the highest apartment rent price? Let's just ask this question. And Cortex is trying to answer our question. And you can see the Cortex said Vancouver has the highest monthly rate and based on this query. And the query is automatically generated. Again, we as a data analyst or data scientist should understand and confirm this piece of query. Or we can say, can you let me know which city, let's say which property ID has the highest number of bathrooms. We are looking forward to see which property ID has the highest number of the bathroom, and we can see this property ID has 5 bathrooms, which is very interesting. Alright, we saw that how we could handle this project and apply and implement this wonderful project. We walked through all the steps. We first understand what is the problem for stakeholders, what is the real issue, what we are looking for. After that, we just grab the raw data and store them in a cloud provider as a S3 bucket in AWS. Then we ingested those data in Snowflake as our sophisticated data warehouse. Then we transform data with Python to the format that we would like. And after that, with SQL in Snowflake, we run some SQL queries for sake of exploratory data analysis. And finally, we create a semantic model to have the ability to use the natural language query to talk with the data with our language, not writing the query. And Snowflake and AI just create those queries for us. But we should take care about the queries to confirm them they are correct or not. I hope you enjoyed this video, and thanks for your watching.